So let's take a look at this one. We're going to take a look at some gas laws. And gas laws, basically, you got to plug stuff in. One thing about the gas laws, always remember, the temperature has to be in Kelvin. So when we work these problems out, always convert it to Kelvin first. We'll work at some of that. Let's take a look at this one. It says the volume of air in a syringe. So say you have a syringe, you pull the plunger out. Say it's 10 milliliters. And say it's the pressure at 765 millimeters of mercury. So about atmospheric pressure. Now we're going to figure out that once I get that syringe, start pressing it in. And notice once you put a syringe in and with air, it gets harder and harder to press in as the volume decreases. That's because of Boyle's law, which basically says now, as the volume decreases, the pressure goes up. And so we're going to decrease it, so the amount of air gets smaller and smaller, and we'll figure out now the new pressure of that air in that syringe. So we push it in, and then we squeeze to a volume of 2.5 milliliters. We went from 10 to 2.5. The way I do is I like to plug stuff in, write down what I know, etc. Well, I know my initial volume, and for initial volume, I like to write V1. Sometimes people write VI, but this is just V1. And my initial pressure, this is my initial pressure, that is 765 millimeters of mercury. For this type of problem, doesn't really make a difference what the units are as long as you're consistent in terms of volume and pressure. So I squeeze it in, and so my final volume, which is called V2, that is 2.5 milliliters, and I want to figure out what my final pressure is going to be. Couple of things before I plug it in. Notice that my volume went down. And so I know my pressure is going to go up. So it's always a good way to check yourself. My pressure has got to be somewhat greater than 765 millimeters of mercury. So volume went down. I squeeze it in the air in that syringe. Less confined space. Air molecules hit the size of the container more often. The pressure is going to go up. And so my pressure is going to go up. The law to use this whenever pressure and volume are changing, it's going to be Boyle's law. It kind of gave it the hint away. And so let's plug it in. Let's do P1, V1 is P2, V2. Solve the equation for P2. You can solve any way you want to, but basically I need to get P2 by itself, so I'm going to move V2 over to the other side as the denominator. Then you're set. So let me just set up something like this. In fact, I reversed it. Should be this. P1, V1 over V2. So I moved over as a denominator. Let's plug it in. My volume should cancel out, and I should be left with pressure. And so when I do that, whenever you're doing this, always check yourself. You notice I almost made a small mistake. My V1 is 10 milliliters. My P1 is 765. Always make sure you're plugging the things in correct. I've seen a lot of mistakes with that. My milliliters cancel out. And my new pressure now, my final pressure, is, I think it's 3,060 60 millimeters of mercury. And notice, check yourself, it did go up. It went from 765, volume decreases, my pressure went up. So, to take a look at this problem right here, it said a balloon at room temperature 20 degrees Celsius. So I have a balloon, 20 degrees Celsius. I'm going to cool it down to 0 degrees Celsias. So I cool it up by doing an ice bath. And my new volume is 35.5 milliliters. What was the volume of the balloon at 20 degrees Celsius? Couple of things when you're trying to figure out which gas law to use is write down what you know and then see what you're looking for and then plug in, apply the correct gas law. Well, this is my initial temperature, so T1. So at 20 degrees, my final temperature is going to be 0 degrees. This is my T2. Couple of things. Before you start plugging stuff in, convert that Celsius to Kelvin. That's the main thing. So convert to Kelvin. So at 273 to get it to Kelvin. That's a must before you plug it in. You can't plug it in afterwards. You got to plug it in before. So I have 20 degrees Celsius at 273. Okay. That's my initial temperature. My final temperature is T2. Okay. 273 Kelvin. Was at 20, went down to 0. Again, convert that to Kelvin, because we got to plug in these Kelvin numbers. My final volume, so it's going to be my V2 now. This is my V2. It's 35.5 milliliters. I'm trying to figure out what my volume was at 20 degrees Celsius. That's going to be my V1. So basically what I'm looking for is my V1. A couple of things about that. Whenever you're changing volume and temperature, the gas law is going to be Charles's law. So V1. So again, you just got to look at what you're looking for and apply the correct gas laws. With this, temperature has to be in Kelvin. A few things about this one. Volume goes up, temperature goes up. It's directly proportional. Volume goes down, temperature goes down. For Boyle's law, that was inversely. But for this one, it's directly. And so what happens is, if my temperature is at, say, 293 Kelvin, that's going to be a higher temperature. That's going to be a higher volume than 273. So basically, what's going to happen was V1 has to be greater than V2. So again, it's kind of like looking like backwards in a way. This is my final volume. This is my final temperature. My temperature before was higher, so my volume has to be higher. So I know that V1 is going to be greater than V2. It's always good to do that. Always a good way to check yourself. I'm going to solve this equation for V1. So a couple of things. I mean, I'm not a math teacher. I'm going to cross multiply and solve for V1. So I'll cross multiply. So I get V1, T2, T1, V2. I'm going to bring T2 over to the other side as a denominator. So I'm going to end up with T1, V2 over V1. The way to check yourself, my volumes should cancel out. Make sure I got this right. Hold on. Yeah, my volumes should cancel out now. In fact, I made a small mistake here. So I made a small mistake. T2 goes up to the other side. So T1, V2 over T2. Again, always check yourself with that. That's always the tricky part. Then we plug this in now. So my V1 is 293 Kelvin. My V2 is 35.5 milliliters. T2 now is 273 Kelvin. So check your units. My kelvins cancel out. And this volume, if it works out correctly, should be greater than 35.5. So when I do that, my volume is going to be 38.1 milliliters. So again, it is greater than the 35.5. So again, it's not difficult, but you have to be careful, especially when you cross multiply, to make sure you solve them for the right ones.